Hello, welcome to part 2 of supporting your science teachers in their planning using the instructional unit guides. You should already have an internet browser open and you should already be on the electronic copy of the 8th grade instructional unit guide. You should have the unit planning sheet in front of you and you should have a hard copy of the 8th grade unit guide in front of you. And that way we can go ahead and continue on. If you don't have all that ready, you might want to go ahead and watch part 1 so that you do have that at your fingertips. So let's continue on where we were. We'd already covered several slides in part 1, and we're going to continue with where we left off so that we can get going again. And my computer's being a little bit slow, but here we go. So on Unit 1, Unit 1's a little different from the other units. It's going to look a little different. It is the same for all 3 grade levels as far as expectation, but the activities are different. And Unit 1 is establishing lab safety, class procedures, rituals, routines. We have here it goes weeks 1 through 3 and throughout the year because there are times that teachers do need to retouch on those. One of the things that Unit 1 has all of the 6th, 7th, and 8th grade teachers doing are the math ELA integration units. We call these mini modeling units. And they're important because it's a way that you can establish whiteboarding in the classes at the very beginning. If you don't know what whiteboarding is, you might want to give me a call and I can come out and talk with you. But basically it's a initiative that we're trying to make sure that our teachers are using. We're actually doing it now 4th through high school. And the nice thing about whiteboarding is that it does hit all the ELA, the reading, writing, speaking, listening, and it supports the math initiatives. And it's a great way for students to start speaking as they would write with claims and evidence for science. So we do want to encourage our teachers to be doing that. Some information that's on these unit sheets we'll be covering here as we move along. They have the unit title. We also have the time frame, and then we have a comment section. Questions to assess student learning is basically, like the essential questions, and then where teachers can go to get more information. In this case, they can go to the trainings that we've been offering for mini modeling. The next thing that's on these sheets are the activities and the resources. The activities sometimes are linked, and sometimes it's just the name, and then other links are provided. You will see Science Portal page quite a bit because we are using that as kind of a clearinghouse area, like a hub for the activities that we are putting on, a central place for teachers to find what they need. So let's go ahead and look at planning for Unit 2. We want to be on page 7 of the instructional unit guide for 8th grade, and we're going to kind of go through that unit planning sheet. The very first thing on the unit planning sheet asks them for the unit name or topic. And those are supplied on our instructional unit guides. It'll say unit, and in this case we're doing waves. In parentheses it says thermal energy transfer. That is not part of the actual name. You could go back to that very beginning sequence of units on the inside cover, and you'll say Unit 2 is waves. And so Unit 2 is waves. That thermal energy transfer is actually going to be part of the big ideas of the unit. We'll get into that a little bit more here later. So the next thing that they need to notice on this unit is that the unit actually covers more than one performance expectation, and that's very typical of Next Gen Science. You tend to do a lot of things at one time, and it shows the relationship that you have within the science itself. So what I'd like for you to do if you're on the electronic copy is to scroll down to page 13. If you have one of these a hard copy, flip through pages 7 through 13 and see what do you notice as you're looking at the performance expectations on those pages. What I hope that you have noticed is that on page 7, that page is about MSPS 3.3, which is one of those performance expectations. And page 9 is about the next one, MSPS 4.1. And then the next page, 11, is MSPS 4.2, and 13 is MSPS 4.3. So each page is a different performance expectation, and the information on each page is different for that particular performance expectation. But they all four go together to create that one unit called waves. So it's important that teachers understand that there are multiple pages for the unit. That's probably the first thing that they're misunderstanding when using these. So the next thing that you'll need to do on that unit planning guide is to look at the time frame. And on this unit, it's set for weeks 4 through 7, which is about 4 weeks of instruction. So your teachers are going to have to figure out how much time are you going to give for those different performance expectations. And in this case, it comes out to about 4 expectations, and 4 weeks, you could do 1 per week. That may happen and it may not. Some of those concepts are much easier to learn than others. So this is where it helps to have a teacher who's kind of experienced with the content. We are offering the first Thursday of every month a planning session where teachers can come and work together to plan out their unit. Our first one is October 1st. We'll be at AMAC in room 307, and teachers can come together and sit down and plan out their units so that they can make sure that they're giving the amount of time that's necessary for each one of those performance expectations. So anyway, as we move through this, you want to look at the planning and put the dates on that form. The next thing that the teachers might want to be working on is the big ideas of the unit. A lot of times they'll come like in those parentheses where with thermal energy transfer. Other times the teachers can get that information by going to the performance expectation themselves. And I'm going to show you how they would do that. So I'm going to get off this PowerPoint and I'm going to go onto the web, onto the electronic copy of the instructional unit guide. And here's where you're going to see why this is so helpful. Okay, I'm on my electronic copy, and I'm going to go to the Waves unit, and I'm going to click on that very first one, and you see it's going to take me right to that performance expectation, which was 3-3 right here. Okay, I can then come down over here. I can see what is going on with here. I can come down here to this orange box here, and I can see that here's the information that we're trying to get through when we do this particular performance expectation. So we have definitions of energy, we have conservation of energy. I can click on any of those and it will take me back to the actual framework, which is the reference document for teachers to understand what is it that students should be learning. And they can then understand that this is the essential information that students need to understand when you're talking about that performance expectation. So that's why the electronic version is so powerful for the teachers, because they have all that information right there at their fingertips. So they're going to be using that information to determine those big ideas of the unit. And a lot of times it's just that bolded information, but they might want to click on it and see exactly what do they mean by that. Okay, so let's go back to our actual instructional unit guide and see, and I'm going to take you back to the PowerPoint so we can continue on where we were. So now we know how we can get that information for that big ideas. Let me see. I'm going to go from the current slide here. Okay, so you can understand how you have all these different these performance expectations, but they all come up to make waves, and you have to click on each one of those to determine what it is that you're trying to, the content you're trying to get at. So there's a little bit more to planning than just writing out information off the instructional unit guide. Let's go back to page 7 of the instructional unit guide and look again at the performance expectations that we're covering in this unit. And we did click on that first link, and you can do that now. You can go and kind of see that it takes you to that Next Gen Science Standard site and looking at that particular evidence statement. What is it that you want students to learn from this unit? Well, we need to find that out. We have to look at page 6. And here's where the unit itself becomes very interactive. as far as being online and why we want the teachers to use that online copy. Again, I'm going to go back to that online one so that we can take a look at this. And we're going into page 6. And I want you to look at this lovely, beautiful color copy here. The thing that the teachers need to be understanding is that the information supplied on the electronic is a lot of times a lot easier to see when you go to the actual site. We had to make them kind of small on the instructional unit guides. It's hard to read. So we go to the actual site and bring it up. It's a little bit easier to read, which is nice for the teachers. So when we say what is it that students are supposed to be getting out of this, we have to look at what's called the evidence statements. And these statements drill down. When teachers say what's going to be on the assessment, you have to say it's on the evidence statements. That's what's going to be on the assessment. This is what students need to be able to do to say that they're proficient. So they would have to be able to identify that thermal energy is transferred from hotter objects to colder objects. So you would want them to do some sort of a lab where they're understanding that if something's hot and you put it in cold water, the cold water then heats up. So you're transferring energy from hot things to cold things, right? And they could get that. They can identify that that's going to happen. So if a question says, if, you have hot washers put into cold water, what happens to the water? The water heats up, okay? So it's that type of thing. That's how the students are going to be knowing what it takes to be proficient, and how the teachers are going to know, okay, here's all the stuff I have to cover. One thing I want you to realize about this is that you cannot expect one lab to cover all of these things. So it's going to be multiple exposures in multiple different ways for students to really understand these things, okay? And that may be a little bit hard for some of your teachers to understand, that you really do have to do that multiple exposure. Let's go ahead and look at page 6 some more and drill down into what's happening on that. The evidence statements are a little hard to read, like I said, so you can make them bigger by going to the link. That this is what the students should know by the end of instruction. So it may take more than one activity to do that. And teachers have to choose activities and labs that will cover several items, because we don't have unlimited time. And students need multiple exposure. So just because a teacher has a lab that they really think is great and kids love, it doesn't mean it might be the best thing for the students' learning. We have to make sure that what we're doing is going to cover the information in a timely way, and a way that's going to allow students to have multiple exposure. That's kind of been the one sticky point of all this, is that we do have to give up some of our longer term project type of things in order to really get at learning. And that's not easy for some teachers to do. So kind of be patient with them on that. The other thing that page 6 talks about are on those evidence statements, the science and engineering practices are hit very hard. They say things like design and build and describe and evaluate things. Those are the science practices, and they're much like the math practices. It requires a shift in how we teach. So when we look at those evidence statements, I want you to notice that students have to be able to apply the content. They can't just be memorizing information. Our secondary teachers are having a little hard time accepting that, okay? They want them to be able to memorize all the elements in the periodic table, and now I've taught periodic table. And the reality is a student doesn't need to memorize anything on the periodic table anymore. Periodic tables are on all of our cell phones and everything else that we desire. We just download an app. What we do need to be able to do is utilize the information. So spending 6 weeks memorizing a periodic table is not going to be worth the time. What you do need to do is you do need to have the students using information from the periodic table and being able to understand patterns and trends and predicting the next element, that type of thing. Okay, we're about out of our 15 minutes of time, so what I'm going to do is wrap this up for this section, and we will have part 3. So I would like for you, MTSS facilitators who are using this at Friday Learning Lab, to end here and then go ahead and start with part 3 so we can continue on. Thank you.